So here we will do a demonstration on the working mechanism of proof of sense blockchain network. So these are the workflow of the consensus algorithm. So we have divided it into 5 major steps. So in step 1 we have the our sensing enabled blockchain nodes. So these nodes generate keys and sign them and then transmit them in this step 2. So here you can see our test bed. So here we have 4 nodes. Each node have a processing unit and a spectrum sensor. So here the processing unit is a Raspberry Pi 4 device and the spectrum sensor is a HackRF1 SDR. So SDR is a radio communication device that let us do implementation by means of software compared to traditional hardware-based implementations. So SDRs provide us with several benefits such as flexibility, rapid prototyping, and it's also easy to update, and also it reduces the deployment cost. So in this project we have used HackRF SDR. It's a budget SDR. So to do the software development in SDRs, we can use the free development kit GNU Radio. So it let us create a flow diagram using signal processing blocks to implement the workflow we want. Next, in the step 2, we transmit keys. So and then in the step 3, we receive these keys. So we can show this using a simulation. So here in GNU Radio, we are doing a key transmission and receiver simulation. So here we are first giving our keys to a tag stream, and then we add some headers, and then we use a constellation modulator block to do BPSK transmission, and then we have the model the channel using the channel model block, and then we have some blocks at the receiver end to recover clock and to get rid of inter-symbol interferences and do different kind of error correction and reconstruct what we are receiving. So if we run this simulation, we can see what the receiver is receiving. So it's spread all over the IQ plot due to the channel effect, and then once we do the error correction, we can get a clear signal. Since we are using BPSK modulation, this is what we expect. So if we see the data we are receiving, so here you can see we are receiving keys from 3 nodes. So these keys, then the blockchain client use this to generate proofs associated with the proof of sense consensus mechanism. And here you can see the blockchain client running. So this blockchain client collect these keys and generate the proofs. So here you can see we are using 4 nodes and we have set the threshold to 3. That means only 3 keys is enough to create the next block. So when it has enough blocks, the node will mine the next block. We can also see these details in our dashboard. So we can see the recovered keys and the current threshold and number of total nodes in the network. So in the next step, we generate the block. So to generate the block, we need certain data such as the proofs associated with the key recovery and also the spectrum data we collected. So here you can see we have added the spectrum data into the block. So here on our dashboard, you can see the detail of the last block. So here we put our data to IPFS database, and then we add the IPFS hash into the block. So that way we can prevent the chain from growing unnecessarily. So here we can use this IPFS hash to retrieve data back. Here you can see there are multiple IPFS hash entries in spectrum data. That's because we have uploaded multiple spectrum data sets during the mining of that particular block. you can see that in this IPFS GUI, the data is being uploaded to local IPFS node. So you can see the activity in this dashboard. And if you want to retrieve data, we can retrieve data by the IPFS hash. So here we have structured data in a JSON format. So if we put this JSON data in a JSON format, we can more clearly see how the data is arranged, and you can see all this data. Later, the system will use this data to process and make meaningful decisions about the spectrum allocation, and also to detect spectrum violations if there are any. So, and in this fifth step, we do the verification process. So once a node create the block and transmit it to other nodes, so other nodes will verify this block themselves before they add it to their local chain. So here we are doing the verification process using an elliptic curve based zero knowledge proof followed with the Snow scheme. So here prover collect multiple keys and generate a final key A. So this so in the verification process we need certain parameters. So the prover generate these parameters and add these parameters in the block. And once other nodes receive this, so they have the necessary parameters to generate the verification. So then they can verify whether the node actually collected these keys, and if so, they can add the block to their existing. So now we can see how the proofs and data is added to the chain. So here we have a chain with two existing blocks. So if we continue this program now, we can see at the mining stage the blocks the miner create a new block with this proof. So here we have point A and some scalars and some other points. So these are points on elliptic curve. So here we have used K256 crate in Rust for elliptic curve operations. So if we continue from here, then at the verification stage we need to derive 4 other points, and then we need to do pairwise matching according to the Snow scheme. Then we can conclude that this proof is in fact correct. So if we continue from here, so here now we have 3 blocks. That means the new block is added to the chain. So if we expand this block, we can see the data index, timestamp, proof, previous hash, and some sample data. And inside proof we have these 4 parameters, and these are basically elliptic points. So we have x coordinate, y coordinates, and data like that. So here in our dashboard you can see the data of local chain. So you can see current block number and average block time and average block size. Also you can see the size of each block against its index. So you can also see the detail of the last block. So we have timestamp and all the other proofs that was used in the zero knowledge. And we have not included transaction set to our network. Also you can see the spectrum data here as well. So right now for the demonstration, we are running 4 blockchain nodes locally. And from the dashboard, we can see overview of these 4 nodes. So you can see how many keys have each node been recovered so far. So these number of keys recovered dynamically update for node based on how many keys they recover. So here node 4 have 1, and right now it has recovered 2 more keys. This is the end of our demonstration of our proof of sense blockchain network. Thanks you all for listening.